This is officially the fourth time I have done this video. So hopefully it's just getting better and better each time. Alright, to start off, let's talk about the actual chain rule. That's when you have a function which is actually a composition of two functions. What you'll see in in the textbook, the notation we see is taking the derivative of f, leaving the g of x on the inside multiplied by the g primed of x. But in class, you'll hear me say, take the derivative of the outside, leave the inside exactly the way that it was. Let's see, that is definitely not how I write it in class. Leave the inside exactly the way that it was, multiplied by the derivative of the inside. And this is the only time you hear the word multiply. I'm going to use your quiz from October 29th as a review of chain rule and a review of your trig rules. So first thing I'll look at is that the outside function for this would be negative 4 cosine of. The derivative of my outside function would be, leave the negative 4 in front, take the derivative of cosine. See? Therefore, we end up with 4 sine of a function. Really, what you would put inside of there is another variable like u. Your inside function is at 5x squared minus 1. The derivative of your inside function is 10x. And if you do it in this order, you'll notice that these three are actually what get you the derivative of f. Take the derivative of the outside. Leave the inside exactly the same as you saw it before. Multiply by the derivative of the inside. So we did derivative of the outside, put the inside back, multiply by the derivative of the inside. And so the final answer for this one becomes 40x sine of 5x squared minus 1. Looking at the second problem that we had on the quiz. Cosecant, your outside function would be the cosecant. Therefore, the derivative of the outside is negative cosecant of cotangent of. Your inside function would be 6x plus x squared. The derivative of the inside would be 6 plus 2x. And we're going to use these three to create the derivative rule. Let's see, g primed of x, derivative of my outside. Leave my inside exactly the same as I saw it before. Multiply by the derivative of my inside, which is 6 plus 2x. Yes, you have to have these parentheses because that whole thing is being multiplied. When you simplify this guy, we get negative, bring the factor out front, cosecant of 6x plus x squared times cotangent of 6x plus x squared, and there's really nothing else you can do to the function. Yes, you have to have these parentheses there. Next problem. I would rewrite this problem. When you see a square root, if you want to use the power rule, you want to make sure that you see that it's a power rule. So the easiest thing to do is rewrite it with a power. That way you can kind of see, here's your outside function. You're taking something to the 1/2 power. So the derivative of the outside, multiply by the power in front, and then take the power down by 1. So that's negative 1/2. Your inside function, and I'll put that off to the right. Actually, I can squeeze underneath. Your inside function is secant of 2x. The derivative of the inside, that's another chain rule. So, derivative of my outside. Leave my inside exactly the same as you saw it before. Multiply by the derivative of my inside, which is just 2. And these three together will make us our derivative. The derivative is the outside derivative of my outside. Leave the inside exactly the same as you saw it before. Multiply by the derivative of my inside, and I'm going to actually pull this 2 out front, then put secant of 2x, tangent of 2x. Okay? What you should notice is that this 2 and this 1/2 will cancel and give you 1. We can rewrite this to be the secant of 2x to the negative 1/2 power, secant of 2x, tangent of 2x. And these two terms can be combined. And the reason why, I'll do that up here. If I had x to the negative 1/2 times x to the, and we'll call it the first power so that you see it. If they have a common base, what would you do to the powers? You would physically add them. And so negative 1/2 plus 1 gives you positive 1/2. Secant of 2x down here is considered the base. And the powers are exactly as I put up there. So your secant of 2x, the power becomes positive 1/2 because negative 1/2 plus 1 makes positive 1/2, and then tangent of 2x, which you might want to rewrite as secant of 2x with the root and then tangent of 2x. And that's where it's being multiplied. Third problem, this is another double chain rule problem. I'm going to rewrite the problem. And just so you don't get confused, I'm actually going to eliminate the parentheses on the inside. Just know that the tangent, the input is negative x squared. Hopefully you see that the outside function is the negative 2 to the third power. And the derivative of the outside function would be negative 6 to the second power. The inside function is tangent of negative x squared. So I'll put the parentheses back for this one. And the derivative of the inside would be a chain rule. Here's my outside function. The derivative of tangent is secant squared. Leave my inside exactly the same as you saw it before. Multiply by the derivative of the inside, which is negative 2x. Therefore, the derivative of k would be these three. Derivative of my outside. Leave my inside exactly the same as I saw it before. Multiply by secant squared of negative x squared times negative 2x. We are going to combine and multiply these two factors. And I get that 12x, and then multiply by tangent. And the term is squared, so I'm going to move the squared on the inside, put back my parentheses, and the secant, same thing, squared on the inside, put back my parentheses. There's your final answer for the fourth quiz question. Then the very last here is the fact that you're trying to find derivatives using a table. And off to the right here, let's see, actually I'll do it right underneath. The derivative of h would be found, this is a chain rule, this is your outside, this is your inside. Derivative of my outside, leave the inside exactly the same as you saw it before, multiply by the derivative of the inside. And I'm trying to find this derivative at 2. So, you will be finding g of 2 multiplied by g primed of 2. So, I'm going to try to highlight a few things for you. On the inside here, g of 2 is 1, and g primed of 2 is 4. So how do you use that inside of the problem here? F primed of, and g of 2 was 1. Let's put back the 1, and I actually will use yellow. Hopefully you can see that okay. And then multiply by g of 2, which is 4. Most people are trying to do 1 times 4, and that is incorrect. F prime, the input of F prime is 1, so the 1 belongs to the blue F prime. Therefore, F primed of 1 is negative 3. So you get negative 3, then you can multiply it by 4, and your final answer is negative 12. Looking at the second problem, I'm going to rewrite the problem for you so that you notice that j of x is the same thing as taking g of x and the whole quantity squared. So what does that mean for us? When you take the derivative, you will have to do a chain rule. Derivative of my outside, leave the inside exactly the same as you saw it before, multiply by the derivative of the inside. And I'm being asked to find the derivative at negative 4. So I'm going to do 2 times g of negative 4 multiplied by g primed of negative 4. So we'll use colors again, and this time try to use different ones. So g of negative 4, I probably shouldn't use exactly the same color. G of negative 4, g of negative 4 would be negative 5, and then g primed of negative 4 would be 1/2. So to put that into the problem, we have 2 multiplied by g of negative 4 was the negative 5, and then multiplied by g primed of negative 4, which is 1/2. So the functions that we had, we actually evaluated them completely, and you are left with the value of negative 5. So that is a very quick review of chain rule along with your trig derivative rules. You do need to be able to do both, and mostly in combination.